4.6 day 1 is on inverse trig functions. So our goal today is to construct the graph of inverse trigonometric functions. Starting off with example 1, if the function f is defined by f of x equals 2x minus 3, we're going to find the equation that represents the inverse of f. So if you remember from last year when you were doing inverse functions, f of x, remember, is the same thing as y. So this equation is the same as y equals 2x minus 3. And then to find the inverse, we switch x and y. So if we were to switch x and y, this would become x equals 2y minus 3. And then we would solve the equation to get y by itself. And then we have our inverse equation, which remember is represented by the -1. So for the second part of example 1, we are going to graph both of these equations. Our first equation is 2x minus 3, which means it starts at -3 and has a slope of 2, where it goes up 2 over to the right 1, or down 2 to the left 1. And that would be our original equation of f of x. Then our second equation, if we were to write this in slope-intercept form, we would have 1/2 x plus 3 over 2 equals y to the -1. So that means we're going to start at 1.5, and we have a slope of 1/2. So if we go up 1/2 over 1, we would get a point that's on an actual point of 1, 2. So we can use that to go up 1 over 2, up 1 over 2. Or down 1 to the left 2, down 1 to the left 2. Oh, I think I miscounted there. There we go. And now we have the graph of our inverse function, which is represented by f to the -1 of x. And if we were to look at a few of these coordinate points, let's pick this one. We have 0, -3. And if we look at the corresponding point on our second graph, our inverse one, you'll notice that's at -3, 0. And if we chose maybe a point up here on our inverse, that one is at 7, 5. And if we look at this corresponding point on our original function, that one is at 5, 7. So you'll notice the difference between our original function and our inverse function is that we just swapped the x and the y coordinate points. And that's going to be the same thing for our inverse of sine, cosine, and tangent. So the first thing we're going to do is we're going to graph the inverse of y equals sine x. So really quick, we're just going to sketch a graph of sine, which we know goes to 2 pi, pi over 2, and 3 pi over 2 goes up to 1 and -1. Hopefully by now we're getting pretty quick at just graphing a plain old sine function. All right. So the inverse function, we are going to be switching x and y. And that also means we're going to be swapping our labels on our x and our y coordinate. So instead of having the pi over 2 pi on the x-axis, that's going to change to our y-axis. So here we can have pi over 2, pi, 3 pi over 2, and we'll extend it as we need. Negative pi over 2, negative pi over 2, negative pi, and negative 3 pi over 2. And one thing you need to know is for the restrictions, for our sine function, x has to be between negative pi over 2 and positive pi over 2. Oh, sorry, and this is our restriction on y. Sorry about that. And this is something you are going to have memorized. So make sure you have that memorized. So if we go to our graph and we look at our coordinate points, the first one is 0, 0. So if we were to switch those around, it would still end up being 0, 0 on our coordinate grid. So we have -1 and 1. Then if we look at our next point, we go to pi over 2 to 1. So if we switch that around on our inverse graph, we would go to 1 and then up pi over 2. And if we look at our restrictions, which again you want this memorized, we have to go to negative pi over 2. So if we add the negative pi over 2 on this graph, our next coordinate point would be at -1. So switch that around for our inverse, we would go -1 and negative pi over 2. And because of those restrictions, this is all that we are going to need for our inverse function. So all of this you want to have memorized for the test. Everything that is over here. And this is the graph for y equals the inverse of y equals sine of x. And this is something you need to have memorized. All right, next we have the graph of y equals cosine of x, and we need to do the inverse. And our restrictions for this one are between 0 for y all the way up to all the way up to pi. So that means on our y-axis, we just need to go from 0 all the way up to pi. And our x-axis is now becoming the -1 to 1. And if we were to look at our cosine function on a graph, that goes from 1, 0, -1, 0, 1. So if we were to do that, our first point is at 0, 1. So on our inverse, that's going to become 1, 0. Our next point is pi over 2, 0. So we're going to go 0, pi over 2. And our last point is pi, -1. So on our inverse, we would go -1 pi. So now we have this function for our inverse cosine, and it ends at these coordinate points. So it doesn't go any further than this coordinate point. Let me draw that again. There we go. And again, just like the sine one, this is something you need to have memorized. And this one is the inverse of cosine. Okay. And last, we have our inverse of tangent. So our inverse of tangent, is going to have the restrictions from negative pi over 2 to pi over 2 for our y values. So if we were to really quick draw our tangent function, one cycle of that goes from negative pi over 2 to 2, and that's where our asymptotes are. And then it goes at negative pi over 4, 0, 0, 0, and then pi over 4, 1. So if we were to look at these coordinate points, negative pi over 4, negative 1, I don't know what I'm writing over here, pi over 4, comma 1. If we were to switch that around for our reciprocal, or sorry, our inverse tangent function, that would become negative 1 and then pi over 4. That one should be a 4. So for this, that would become negative 1, negative pi over 4. So our first point would be there. And then our point 0, 0 would stay at 0, 0 for the inverse. And then we have pi over 4, comma 1. So that would become the point 1, positive pi over 4. The asymptotes for this one, if we were to pick one point on that asymptote, for example, this one, that's at negative pi over 2, 0. So if we were to switch that, that would become 0 pi over 2. And our asymptote, instead of being vertical, is going to be horizontal on our inverse function. And that happens at negative pi over 2 as well. And then that gives us what we need for our graph. And our restrictions for this one, again, is from negative pi over 2 to pi over 2. And again, just like the last two, this is something you need to have memorized. So these three inverse functions, the graphs and the restrictions, you will need to know for tests. All right, next, we are going to evaluate in radians without using a calculator or table for these. So for this, we're looking what x equals. So we know that the inverse sine of 1/2, that's what we have, and we're looking for what x equals. So what we're going to do is draw this on a right triangle on our coordinate grid. And we know that the inverse of sine has a restriction between negative pi over 2 and pi over 2. So negative pi over 2 to positive pi over 2. So our only answers that are possible are between those two values. And we know that this sine is going to be 1 over 2. And this is part of one of our special right triangles, the 30, 60, 90. And we just need to figure out what 30 degrees is in radians. And if you have that memorized, you would get pi over 6. If you didn't remember what it was in radians, remember you just multiply this by pi over 180. And then once you simplify that, you would get pi over 6. And that would be our answer. Our next one, arc cosine, this is the same thing as cosine negative 1 of negative square root of 3 over 2. So arc cosine is the same thing as our inverse cosine. And arc sine, I know it's not on here, would be the same thing as inverse sine. So we're going to do the same thing. We are going to draw our graph. And remember, our restrictions for cosine or inverse cosine are between 0 and pi, which means we can only have a value that's between 0 and pi over here, nothing else. So our cosine is negative, which means that it would have to be in the second quadrant. So we're going to draw our triangle in the second quadrant. We have negative square root of 3 over 2, which again, this is one of our special right triangles, which would be 30 degrees. But remember, we are looking for this angle on the outside. So our answer for this, because we already know 30 degrees is pi over 6 from our last example. So we need to figure out what pi minus pi over 6 equals, which would just be 5 pi over 6. And that would be our answer. So for these, we're really just looking for the original angle that we would be evaluating. So then next, we have the inverse function of tangent equals -1. And remember, the restrictions for tangent, the inverse tangent, are from negative pi over 2 to pi over 2, which means we're either in the first or the second quadrant. So our restrictions are from pi over 2 to negative pi over 2. And because this one is negative again, that means we're going to be in the fourth quadrant because in the first quadrant, tangent is positive. So the only time tangent could be 1 would be 1 and -1 here. So that means we have our 45-degree angle here, which in radians is equal to negative pi over 4. And if you didn't know that, you would just take negative 45 because we were going down, and you would multiply that by pi over 180 to change it to radians. And when you simplify that, you would end up with negative pi over 4. Then we can move on to example 6. This time we're going to use a calculator to evaluate. So let me pull up my calculator really quick. Okay, so we're going to use our calculator to evaluate each of the expressions. And remember, for these, we still have our restrictions. So this one, they are restricted to negative pi over 2 to pi over 2. And our cosine, remember, is the same thing as inverse sine, or sine to the -1. And you're just going to type in that value, 0.5075 equals. And remember, this gives you the reference angle. So because sine is positive, that means we will be in the first quadrant. So we can just write down this angle. And we are rounding to the nearest tenth, so we would just do 30.5 degrees for our first answer. And remember, when you type this in, you're only going to type in the positive value. So for arc sine of negative 0.5075, we would still use this 30, but remember, that's our reference angle. So if it's negative, that means we're going to be in the fourth quadrant down here, which would just mean that our angle is negative 30.5 degrees. Then our next two problems, we have our cosine, which has the restriction from 0 to pi. And remember, we only type in the positive value. So we're going to do the inverse cosine of 0.6428. And that's going to help us with both of them because the next one is just negative. So from our restriction of 0 to pi, cosine has to be positive in the first quadrant, which means our angle is just going to be 50.0 degrees. Then cosine has to be negative in the second quadrant because that's in our restricted area that we're looking for. So that tells us this reference angle here is 50.0 degrees. And we're looking for this outside angle. So we're going to take 180 minus 50, and that tells us that our answer here for our second inverse cosine problem is 130.0 degrees. So those restrictions are going to help us find the only angle possible for these. And lastly, we are going to do our arctangent or inverse tangent. And remember, this one is restricted to negative pi over 2 and pi over 2. So our first and second quadrant. So we're going to start by typing in the inverse tangent of 4.474. And the answer for our first one is just going to be 77.4 degrees because tangent is positive in that first quadrant. Then the next one, we have negative value. And because tangent is restricted from negative pi over 2 to pi over 2, this one will have to be in the fourth quadrant because it's negative. So our answer is just going to be negative 77.4 degrees. So in previous chapters, we had to find both values for our inverse function, or when we were solving equations. These ones, when we're working with our inverse functions, don't forget your restrictions. So there's only one possible answer. Okay, so that's going to be everything you need for the homework. If you have any questions,